setup time and its impact on process capacity and inventory. We are going to consider here an example of producing steer support and ribs, two parts for scooters of Nova Cruz that we considered in topic 4. Right? If you recall, in topic 4, we had an assembly line that produced scooters, and each scooter in this assembly line requires two types of parts. It requires one steer support that is produced on a milling machine, we will consider here, and it also requires two ribs, which are also produced on the same milling machine. Right? So the milling machine, when it produces those two parts, it requires 1 hour setup time whenever it is switching from producing one product to the other. So here you have a picture of the milling machine, and then also you see the steer support part. Let us now consider the impact of batch size on capacity and inventory created by the milling machine. So suppose we would consider capacity, calculating capacity for the following batch sizes, having 12 units, 60 units, 120 units, and 300 units produced. Now, we're going to count units as parts for one scooter, right? And recall that it takes one steer support for each scooter and two ribs. Now, we know this is the data. It takes 12 minutes to produce one box of 12 steer supports, which are enough for 12 scooters, right? And the setup time before this production run is started for whatever number of steer supports, right, is 1 hour. And the same, it takes 12 minutes to produce one box of 24 ribs, and the setup time is 1 hour. So in this case, there is a restriction that we have these parts in boxes, and we should actually produce things in multiples of boxes if possible. Right? This is not always going to be. This is going to work, right? This is one box. This is 12. This is 5 boxes. This is 10 boxes, right? And this is 25 boxes. So in this case, if we were to produce in batch size of 12, what would happen? What would happen is we would need first spend, this is the timeline, 60 minutes on setup. Then for 12 minutes, we would be producing one type of the product, right? In this case, the steer support. 12 minutes would produce 12 steer supports. Then because we will be shifting to the other product, we would need another 1 hour of setup. And then 12 minutes for 24 ribs, the other product. And this is a kind of production cycle that would be repeated again over and over, right, if we were to produce continuously, right? So what I want you to see is that within this production cycle, actually the productive time is just 12 minutes here and 12 minutes here for something like over 2 hours long, right? Almost 2.5 hours. And if the batch size was 60, this would be the setup, but the production would be 5 times longer. And the productive time, as right here, the same thing, another 60 units, so 5 times 12 minutes, right? The production cycle would be somewhat longer, but the productive time in this case would be about 50% of all the time, right, used here. And as you increase batch sizes, I hope you see that, right, in this case, the setup time becomes smaller and smaller fraction of the production time. So, of course, I hope you see that there is an advantage here of introducing larger batches because relatively they use relatively better use the resource time. So if we want to do the calculations of the capacity that depends on batch size, we can use this formula. And this formula basically says, right, capacity is what? Number of units at in what time. So it's always units per time, right? This is the normal unit of capacity. So here we're saying the capacity will be calculated as batch size, number of units that we produce, divided by how long does it take to produce this batch. So it takes a setup time, and it takes time per unit times the batch size, right? So this is the calculations. This is in symbols B divided by setup time S plus batch size times processing time per unit. Now, in this case, because we are shifting from one product to the other, both of which are necessary for a scooter, right? We're going to consider the total setup time, which is composed of the two setup times, right? So setup time for one product is 1 hour, and then setup time for the other product is also 1 hour. So the setup time will be 1 hour and 1 hour, 2 hours in total, or 120 minutes. And time per unit, right? We can also consider, because it takes 12 minutes to produce 12 steer supports, that's like 1 minute for one steer support, and 12 minutes for 24 ribs, that's 1 minute for 2 ribs, but remember, 2 ribs are necessary for one scooter. So again, it is 1 minute for every set of parts necessary for the scooter, a set of ribs necessary for one scooter, right? So a total time per unit will be 2 minutes, 1 minute due to the production of steer supports and 1 minute due to the production of 2 ribs, right? 1 minute for one steer support and 1 minute for 2 ribs, both of which are necessary for one scooter. So time per unit, I'll consider it to be 2 minutes, right? And now if you want to calculate the capacity, right, in this case, it will be 12, batch size is 12, divided by, right, setup time 120 plus 12 times 2, which will be 0.0833 scooters per minute, right? If you see here, batch size is 60 divided by 120 plus 60 times 2, right? This will give us exactly 0.25. So 0.25 scooters, if you like, 0 per minute, or 120 batch size divided by 120 plus 120 times 2. That is equal to 0.333, 1/3, right? And the last one, it's 300 divided by 120, again, setup times the same, and here 300 times 2, that will be equal to 0.4166. So you see, as we increase the batch size, the capacity is increasing, right? From 0.08, 0.25, 0.33, 0.41, or 42, right? The capacity is increasing. And in fact, we can see that it is increasing when we are at very small batch sizes. Any increase in batch size is increasing the capacity very rapidly, but then this increase actually saturates, right? And the reason for this is that already at this batch size, the setup time is a very small part of the cycle time. So increasing the batch size a lot is not going to change the capacity, increase capacity significantly. And in fact, we know what the maximum capacity can possibly be. If we had extremely large batch size, the setup time would become completely insignificant. But the fastest we can actually produce those units is 1 unit per 2 minutes, because there is a time per unit, right, per 2 minutes. So if you go to an extreme high batch size, when b goes to plus infinity, the limit of this function will be 1 over p, so 1 over 2, or 0.5. So the maximum capacity we can actually obtain here is 0.5, or 1 over p, 1 over time per unit. So this is the capacity. You see, as we increase the batch size, the capacity is increasing. It seems that we should be increasing the batch size as much as we possibly can, because that improves the capacity, and the capacity increase is what we usually desire. Unfortunately, increasing capacity, increasing batch size also increases inventory, right? Because what will happen here when we produce those two parts? Well, what will be happening is that when we produce one product, we must have the other product already produced before, and we will be depleting this inventory, right? While at this moment, we will be producing the new product, maybe using some of it immediately, right? And then when we shift to the other product, this first product will be depleted and the other product we have to produce. So there is inherent inventory, as we said, right? And if you have large batch, the amount of this inventory will be larger. When you have smaller batches, you keep switching from one product to the other and back, the inventory will be smaller. So you see that we have one reason to increase in batch size in order to improve capacity. But on the other hand, we want to decrease batch size in order to reduce inventory, which is costly, which may hide quality problems and generally create problems. For example, if you shift to a new version of a product and you have some remaining inventory that is becoming obsolete, you have to discard it, and that's an unnecessary cost. So it's always better to have less inventory if it can be avoided without significant problems.